Hey everybody, I want to make this final video of the semester to give you some tips on how to choose between hypothesis tests. This is a thing that's actually really tricky to do. You don't get it as much in this class. This is one major downside of mastery grading, because I have to kind of tell you which hypothesis test you're doing, right? This is topic 12, so you know which hypothesis test, whereas topic 13, so you know what kind of hypothesis test you're doing. And you kind of don't get the full hypothesis testing experience, where the first and most difficult thing that you have to do is select which hypothesis test you're doing, right? What you get is just, and you'll see this on the homework, but what you'll get is just a description, like here's a question you want to answer. What do you do? And if the answer is you make a hypothesis test, well, the obvious question is, well, what hypothesis test, right? How can you tell? So with that in mind, I want to show you some hypothesis tests. So here is a thing that is in fact one of the only things in the topic 16 links. This is the what did I call it? Hypothesis testing decision tree. That's in there. I've got the PDF and DocX version, of course. And the way that I think of what hypothesis tests to do is this way. It's like a flowchart, essentially, where the first two questions you ask yourself almost completely determine what you're going to do. First question you want to ask yourself, what type of data do I have? Is it numerical or categorical? And the second question you want to ask yourself is, how many samples do I have? Or how many samples and or categories, which for categorical data, which we'll see in just a second. And then once you do that, you're mostly home free. After that, it's it's some minor details about, do I know sigma? Is this data paired, et cetera, et cetera. But yeah, you basically want to think like a flowchart. And so what your homework is just a bunch of different problems where I ask you what hypothesis test should you do and why. And the why is going to be something like, well, my data is quantitative and I've got 3 or more samples where I'm trying to determine if all the means are the same. That's an ANOVA test, right? That's what an answer is going to look like on that homework. But yeah, I would recommend thinking about your hypothesis tests in this way. There's a few more down here, right? I've just got it big so you can see. But there's a few more down here, right? So let's go through this real quick, right? Quantitative first, right? So you ask yourself, what type of data do I have? And the way you can tell what type of data you have is picture yourself asking whatever question you're interested in of one of your subjects. So if you are counting number of bees in a beehive, right? You would say something like, excuse me, Mr. Hive, how many bees are in you? And then the hive, the anthropomorphic hive here, would say something like, there are 40,000 bees in me, right? That's a number. So that would be quantitative, right? If you're asking about, excuse me, Mr. Hive, are you within 5 miles of human habitation? Then the hive would answer you yes or no, right? And so that would be a category. So think about what question you're asking and whether the answer to that question is a category, like yes or no, or car color, like what's the color of your car, blue, red, black, white, whatever, like something that has categories, right? Or is it a number? Is it, I am 6 feet tall, or there are 40,000 bees in this hive, or something like that. And that's the first clue about what you're going to do. And notice that once you answer that question, that kind of cuts off about half the choices, right? It looks like there's a lot more quantitative tests over here, but there aren't, because there's a bunch of them are Chisquare, right? Chisquare has a bunch down here that I just couldn't fit over here on the chart. So yeah, qualitative versus quantitative is your first question. Excuse me, numerical versus categorical. I've been calling it qualitative or quantitative for 15 years now. It's numerical versus categorical is the first question you want to answer. And then after that, how many samples do you have? And remember, when you answer the question of how many samples you have, I should be, well, firstly, if there's only one sample and you're comparing that sample to a number, or you're comparing a parameter from that population you're taking the sample from to a number, then you're going to be doing a one sample T or Z test, right? And then the T or Z is determined by whether you know sigma or not. So ask yourself, numerical versus categorical, which kind do I have? Secondly, how many samples? Is it 1, 2, or more than 2? Right? If it is one sample and you have quantitative data, then you know you're doing one sample Z or T, which your calculator just calls Z test or Z or T test. If you had a qualitative, a categorical variable that you were asking about, then ask yourself, how many categories do I have? 2, like yes or no, or 3 or more, like, what color are your eyes? Then ask yourself how many samples you have. So depending on what you've got, once you answer the first question, that's how you determine what the second question is. I guess I don't want to run through this. I feel like I'm being very inefficient about this, but basically, what type of data do you have? Numerical is all these tests. Categorical is all these tests here. And then how many samples? If you have quantitative data, if you have numerical data, one sample gives you one sample Z or T. Two sample gives you two samples Z or T, or excuse me, two sample T. No, I said that right. Two sample Z or T, almost never Z, mostly just two sample T, or paired, right? So you have to ask yourself if your data is paired. This means, is your, are you specifically pairing up one person in one sample with one person in another? The classic example here is, like twins or married couple, or the most classic is before and after, right? You get the results before, results after, you subtract them. That's how you can tell if you have paired. More than 3 samples, or 3 or more samples, I should say, ANOVA. If you have categorical data, the first question to ask is number of categories. If it's 2, we only have a couple of choices there. If we have one sample, it's 1 prop Z. If we have 2 samples, it's 2 prop Z. We don't have anything else. If you have more than 3 categories, 3 or more categories, then you have some variety of chi-square test. In chi-square test, remember, we have either goodness of fit, independence, and homogeneity are really the same test, right? These two are pretty much the same. I should tell you that I made this handout for the math lab, so it's supposed to be as generic as possible. And so this is a thing that we actually did, right, in our class. We lumped homogeneity and independence together into a chi-square test of association, just determining if 2 variables are associated with each other or not. I'm not concerned about the difference between these 2 tests. If you go into a field where you have to do a lot of chi-square testing, maybe it'll matter to you then. But for now, don't even worry about the difference. And then we had these random ones, right? Chi-square test of a single variance. It was, this thing's italicized when it shouldn't be. There we go. Whoop. Hang on. There, that's better. Chi-square test of a single variance. If you are testing to see if certain data is consistent or not, is a certain level of consistent. Our example of this was Stephanie and her argon laser from your homework. 2 sample F test whether 2 population variances are equal or not. And the linear regression T tests whether 2 quantitative variables or 2 numerical variables are associated with each other. It's analogous to the independence test, to the chi-square test of independence, except so this one is for qualitative variables, it's for categorical variables, and this one is for numerical variables. And of course, it's just part of linear regression. So let me make a recommendation to you. You'll find that there is another version of this flowchart in the folder, or in the Canvas file, Canvas page. It looks like this. And the idea here is that you just try to figure out which tests should be done based on exclusively information like, oh, this data, I have numerical data, or I have categorical data, right? It's literally the same thing. I just took out all the tests. Yeah, so you can figure out from the context which test you should do just by figuring out from the flowchart which one you should do. And then, like, for instance, blank tests whether a population variance is equal to a hypothesized number. Well, that is a chi-square test of a single variance. Or blank, test whether two population variances are equal. That's a 2-sample F test, right? And so you can tell from the description of what it does, what test you should do. So I would recommend downloading this, maybe printing it out, trying to fill it out as best you can. And then forgetting, like once you've filled it out once, don't just keep that. Like take that filled out one and put it away and don't look at it. And then once you've forgotten where everything goes, then do it again. And it will be a lot easier the second time around. Probably. Maybe it was easy for you the first time, I don't know. But in general, I would expect it to be easier the second time around. And once you do that maybe a couple times, you don't even have to, you just don't even need the flowchart anymore, right? If you can determine based on just a couple of questions, which of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, oh, I guess that's just, this is Chi-square. So 9, 10, 11, 12, 13, 14, which of 14 hypothesis tests to do with just like maybe 3 questions, right? The 3 questions that you're asking yourself, well, what am I doing in this problem? You don't really need the flowchart anymore. And on the final, you get the flowchart for free. You can just have it if you want it. So feel free to just sit there with this, or ideally, actually, it would be better to use this once you've filled it out. Just the act of filling it out, by the way, will make it stronger in your memory than looking at something that I have done. If it's something that you have made, that will stick in your brain better than just looking at a thing that somebody else has done, because your brain has that kinesthetic memory, the connections forged with whatever was going on around you at the time. I don't want to go off on too much of a tangent, but check out my my learning efficiently video in course resources. Excuse me. But anyway, yeah. So get the blank version and fill it out and use it. You just get this for free on your final. It doesn't count as one of your 2 pages. Or as one of your 2 pages. You can just have it sitting off to the side if you want. And I think that's really all I want to say about this topic. The homework I'm not finished writing all the situations yet for the homework. So we'll get that up to you as soon as possible. But basically it's just a bunch of situations where you can determine which type of test you're doing based exclusively on a word problem. I didn't put them in order. I specifically mixed up the order so that it wouldn't be like in order that we covered them, and it wouldn't be the opposite order that we covered them. It's literally random. I went to random.org and got a random ordering for it. Yeah, that's really all I want to say about this. And that's it for the topic. So when I told you that this wasn't really a topic, this is what I meant. We're not actually doing anything new. It's just a way to practice things that you already know. And with that, I think I will end my last video. That's a little sad. Anyway, I will see you guys for the final. Have a great day, and I will say I'll see you in the next one, but I won't. All right. Have a good time studying for the final, and you can catch me in office hours.